Today we'll be looking at forces, namely dividing into components and looking for resultant forces. These are really important concepts in structural engineering, so join me as we figure this out together. So here you can see the question we'll be solving together. I've got this T-beam, it's bolted to the ground, and I've got two forces pulling on the T-beam. One force of 1 kilonewton in the kind of positive XY plane, and one force of 2 kilonewton, which goes along the positive y but the minus x axis. Now, I am going to solve this in a structural engineering way, meaning that I'm going to look at the forces and divide them into components. You can solve this many other ways, including mathematically, graphically, but I'm going to approach this as a structural engineer. So in order to do that, the first thing I'm going to do is I'm going to separate each of these forces into components. Let's start by looking at F1. The force of F1 goes like that. It is 1 kilonewton, and the angle here is 30 degrees. And if I divide it into its two components, let's use blue for this direction, I can see that I've got a component in the positive x, and I've also got a component in the positive y. Now the positive x component, as you can tell, F1 in the x direction, is going to be the force 1 kilonewton cos 30. And if I work that out, that works out as 0.87 kilonewtons. Now the force in the y direction is going to be F1 in the y direction, 1 sine 30, and that works out as 0.5 kilonewtons. And since I've drawn these already in their directions, I can immediately tell what is in the positive x and what is in the positive y. Let's move on to look at force F2. So the force was 45 degrees in this direction, and it was 2 kilonewtons. And if I divide this into x and y, I can see that I've got a force that goes in the negative x direction. Well, let's just remind ourselves as well that this is 45 degrees here. And I've also got a force that goes in the positive y direction. So breaking these down, F2x equals 2 cos 45, and that is 1.41 kilonewtons. And in the y direction, I've got F2y, which is 2 sine 45, but as you know, sine 45 and cos 45 are the same, so I still get 1.41 kilonewtons in this direction. In order to find the resultant, I need to sum up the forces in the x and the y. Let's start off with the x direction. So the resultant in x, and I'm going to say that this is my positive x direction, right, in the positive x-axis, is going to be the sum of forces in the x direction. And in this case, I've got 0.87 from force F1 and minus 1.41 kilonewtons from force F2, and that gives me minus 0.54 kilonewtons. The y direction is very similar. I have to sum up all my forces in y. In this case, both of them in the positive y direction, so I have 0.5 from force F1 plus 1.41 from force F2, and that gives me 1.91 kilonewtons for the resultant. If I want to write this as a vector, okay, so vector, I'm noting that with the arrow, I have minus 0.54i plus 1.91j. Always pay attention to what you're asked to deliver. Now, I was asked for the resultant force. In order to find the resultant force, what I need to do is the square root of sum of squares. So that means rx squared plus ry squared and a square root of that. In this case, I've got minus 0.54 squared plus 1.91 squared, and a square root of that gives me 1.98 kilonewton. Never forget your units. I'm interested to figuring out what this actually looks like. So let's see. If I've got my axes here, right, this was my x and y axes, I can see that my resultant is positive and 1.9, so much larger in the y direction than it is in the x direction, which is negative. And that means that resultant force will look something like that. I now want to find the angle. This is my angle theta, and I know that if I've noted this is theta, I know that tangent the theta is going to be ry over rx, so 1.91 over 0.54, and that gives me 3.537. And if I do inverse tan of 3.537 on my calculator, I get that the angle is 74.2 degrees. Now I could have done this by taking the actual direction of 0.54, which was negative, which means that the answer would have been exactly the same, just negative, to note that it's from the negative direction from the x-axis. If I want to find the complementary angles, so if I want to find this angle here, let's call it alpha, so I want to find it from the x direction, we know that alpha is 180 minus 74.2, and that gives me 105.8 degrees. So the important thing to note here at the end is the direction. You can give it by alphas. From the positive x-axis counterclockwise to the resultant, the degrees, the angle is 105.8. And we can also give our resultant force, which is 1.98 kilonewtons. And that's it. The most important thing to note is probably dividing into components, maintaining your units, and also showing where the resultant is and what the angle is to get to the resultant. Join me for more structural engineering. Bye for now.